Today's problem is stock buy and sell with Cooldown. If you are doing interview prep, I recommend that you seek out and practice a few of these stock buy and sell things. They're pretty common questions. Lead code probably has at least half a dozen variations of stock buy and sell. So the problem here is, given an array where the ith element of array represents the price of a stock on the ith day, all prices are non-negative integers. Find the maximum profit you can make by buying and selling stock, such that after selling a stock, you can't buy again on the next day. Meaning there is a one-day cool down. Okay? Just look at the examples here. I mean, there's something sort of implied. I don't think it's even implied, but it's it's sort of baked in and not really mentioned at all. But okay, let's do this. That is, well, let's go through the example. You buy on day 1 at 0, sell on day 2, which gives you a profit of 2. Next day has to be a cool down. Then you can buy on day 4, sell on day 5. That'll give you another profit of 1, total profit 3. Something that's not mentioned here. Get a pen for a second. I mean, what's not mentioned is that you can't buy and then buy again. You've got to buy and then sell. Or I guess another way to say it is, you can only hold like one share of stock. Because it looks like the ideal thing here would be, I'm going to buy here on day 1, and I'm going to buy here on day 3, and then I'm going to sell everything on day 5. So what did I make? I made $3 here, $2 here, $5. That's not allowed. Okay? I feel like they should be a little bit more explicit about that you can only hold one share of stock at a time, but okay. Let's see. Next example. You are going to buy on day 2, sell on day 3, so you'll make $5 units. Cool down on the next day, even though it would have been a good day to buy, but you can buy on the next day, day 5, sell on day 6, so you get 5 and 2, 7. Array size will be between 1 and 10 to the 5th, 100,000. The prices will be between 1 and 10 to the 4th, 10,000. Expected complexities, O of n, time complexity. So that's just one pass through the array. Let's see, auxiliary space, O of 1, topic tags, dynamic programming. All right, well, that's worth discussing. Usually dynamic programming, now this is a one-dimensional dynamic programming problem. Usually your auxiliary space would be at least O of n, right? Because you would have a dynamic programming array. Although it's not uncommon that once you get past a certain point in the dynamic programming array, you really don't you're never going to go back. Okay, you don't care about the previous values anymore, and that's the case here. Really, we only care about today's value and yesterday's value. So we can keep track of our profits with 3 states: buy, sell, and cool down. So those are the 3 things that we can do on any particular day. We could buy, we could sell, we can cool down. so we have three variables for those states. We have some supplementary variables here: previous buy, previous sell. That whoa, I don't want to do that. That would what was I trying to say? So that really is like our mini dynamic programming array. It's kind of a sliding dynamic programming array of length 2. Why do we need that? Previous buy, previous sell. Well, we need it because these values are going to be every day. They're going to be updated. But the equations that we use to update them, we still need the previous numbers. So, okay, here we're going to update buy. But to update sell, we need the previous buy value. So we have to save it before we overwrite it. Same thing here on the sell. We need the previous sell value for the cooldown computation. So we got to save it. We don't need to save the cooldown because the cooldown is the last thing. There aren't any additional computations after we update the cooldown. Other ways to do this that would violate the O of 1 constraint would be you could have arrays for buy, sell, and cooldown, but again, we don't care about anything except the previous day, so we don't need the whole array. Another thing, you could have this, you could do the math max sell cooldown computation inside the for loop and have a DP array and just take the last value. We don't care about that. We don't care about that. We don't care about what that math max value would be for sell and cooldown until the last day. So we can wait until the end to do that computation. Also, why isn't buy in here? Math max of buy, sell, and cooldown. Well, on the last day, you can't maximize your profit by buying because you're never going to have an opportunity to sell. So all you can do by buying is reduce whatever profit you have. So we're looking at the max of sell and cooldown. All right. Let me get rid of some of these dots. All right. So let's kind of let's walk through this, and I need to be able to see. We're going to use the second example here, but I need a little extra space to, that should be fine. All right, get a pen. And, all right, the array length can be between 1 and 100,000. If it's 1, then there isn't going to be any profits. So we just return 0. Now, if we let an array of length 1 just go through the algorithm here, it would still return 0, but I think it's better to call out the edge case right here at the top. Okay? So first day, the only thing we can do is buy. So we're going to update the variables. I mean, every day we have an option of, well, that's not quite right, but every day we are going to update 3 states: buy, sell, and cooldown. Now on the first day, all we can do is buy. And if we buy, and we're keeping track of our profit here, that's why it's negative, we are now at -3. Okay? We can't sell, we can't cool down. So those stay at 0. Now, that takes care of day 1. We're going to go to the next day and go through the rest of the array. So previous buy. Previous buy equals buy, which is -3. Previous sell equals 0. Buy. All right. So to update the buy state, there's a couple of things. One is You know, as I already mentioned, we can't just buy and buy and buy. You can only have one share of a stock. So you can either, the buy essentially is you can hold, that is, yeah, you can hold at your previous buy, or you can buy after a cool down. Okay, so previous buy is -3. Cool down minus array at 1. That is 1. So actually, the best thing we can do here is buy on the second day. It's better than buying on the first day. Sell. Sell is the previous buy plus the profit that we could make by selling today. So we bought at 3. If we sold today, we would have -2. It's not great. Cooldown is math max of 0 and 0. So it's still 0. So cooldown means we didn't do anything. As it turns out, by day 2, that's the best thing to have done, is nothing. There's no way to make a profit in the first 2 days. So let's go to the next day. Previous buy, we will update that. Previous buy, what is buy? It's -1. So this will update to -1. Previous sell is -2. All right. Let's see. Buy is math max of previous buy, which is -1, or cooldown minus array at I, 0 minus 6. Well, that's not good. So we're going to leave that at previous buy. Sell. Previous buy is I'm sorry, sell is previous buy, which is -1, plus array at I, which is 6. Oh, that's good. So we could make a profit of 5 here by buying on day 2, selling on day 3. Cooldown, max of cooldown, which is 0, or previous sell, which is -2. So that stays at 0. All right. Next day, previous buy is buy, stays at -1. Previous sell is now at 5. So let's do the computations. Buy is the max of previous buy, which is -1, or cooldown minus array at I, which is 1. It stays at -1. Sell, previous buy, is -1, plus array at I. So that becomes 0. And cooldown is the max of cooldown or previous sell. Previous sell is 5. So actually that is right, because that has to be a cooldown day. We sold on the previous day, so it has to be a cooldown. So our cooldown is 5. All right, next day is, we're here. Previous buy is still -1. Previous sell is now 0. Buy. All right, so if we buy on this day, we got the math max of previous buy, which is -1, or cooldown minus array at I, which is 2. 5 minus 2. That's actually better. That's actually better. So 5 minus, that's 3. What that represents is that we had a profit of 5, and we used 2 units to buy on day 5. All right, sell. Sell, previous buy, -1, plus array at I, which is 2, and so that goes to 1. I don't know actually what that would Well, actually, I do know what that would represent. You would have to, okay, yeah. You would have to have not bought and sold at 1 and 6. That's if you bought at 1, sold at 2. Cooldown. Cooldown is math max of cooldown or previous sell, so that stays at 5. Now we're at the last day. Previous buy is 3. Previous sell is 1. Buy. We really don't want to buy on the last day. Math max of previous buy, which is 3, or cooldown minus array at I, which is 4, 1. So this stays at 3. Sell is previous buy plus array at I, which is 4. All right, previous buy is 3. Now, if we add 4 to that, we get 7. So that seems like a good move to sell on the last day. And cooldown is the max of cooldown or previous sell. That doesn't change. Max of sell and cooldown is going to be right here, 7, and that is actually the correct answer. All right. So that's it. We keep track of the profits with 3 states: buy, sell, cooldown. We compute those every day. And at the end, the last day, after the last day, we take the max of sell and cooldown. That'll give us our max profit. All right, let's get rid of some of these and try to run it. Move this back over here. And I got to scroll this down a little bit. Submit. Oh, you know what? I should have. Oh, I was going to say it. I was going to say I should have done a compile check, but okay. All right, that's it. Again, these buy and sell stock things are pretty common. I recommend that you find and practice a few of them. I know LeetCode has quite a few of them. Go to LeetCode, get the problem list, filter it for the word stock, and you'll see a number of things come up. So okay, so I hope you will like the video, subscribe to the channel, and we'll see you next time.